Hi, EDLD 512 students, Dr. Fox here. I want to demonstrate for you how to run a t-test in Excel. So we're looking at made-up data, and the research question is there a statistically significant difference between student scores under the following two conditions? Individual work versus group work. Now, if you remember, when we were looking at correlation, we said, is there a statistically significant relationship? Now we use a different word with t-test. Is there a statistically significant difference between two different groups? So in this sample, we have a number of students who receive scores from their individual work, and then also a group of students that did group work. And so we're trying to figure out, is there a difference? So a teacher, in essence, wants to know, do my students do better when they do individual work, or do they learn more when they do group work? Okay, so let's move forward. The first thing we have to do here, and I have the steps kind of laid out for us, is to determine whether or not we're going to do an independent or dependent samples t-test. So what type of t-test are we going to run? Now, typically, when it's a paired sample, you have case 1, and their first score was 48, and then a little bit later, at a different time, their second score on the same instrument was a 78. So these, if it's a paired sample, it's like these are the same person. With independent sample, it's like two different groups, just like we have here, are completely different intervention conditions. So we're going to use an independent samples t-test, and you'll notice that, of course, Excel uses a different word, two samples t-test. So we'll see that in a moment. The next thing we want to do is we don't want to discount looking at the mean and the standard deviation. That's our first indication of whether or not there's a difference. So we do that by calculating the mean and the standard deviation for both groups. And we can do it right here. The average, we'll use the function equals average. There it is right there. I'll double click on it, and then I'll highlight the data from group 1. And I'm just calling this group 1 and group 2. The standard deviation equals STDEV. There it is right there. Same thing, grab the data, highlight, and hit enter. The next one is the average of group 2. Enter. And then equals STDEV. And there it is right there. And here's group 2. So let's just eyeball the data. Okay, the mean of group 1 is 69.4, but the mean of group 2, the group work, is 90.2. Right there. I mean, you clearly see there's at least a 20-point difference, or a little bit over, well, almost a 20-point difference between individual versus group. The group work, students scored better. Also, we see that the standard deviation for that second group was a little bit tighter. The variability is, they're not spread out as much as the individual group work. So students' scores seem to be a little bit more spread out with the individual, a little bit tighter, and much better with the group work. So that's just eyeballing the data. The other thing that we can do is calculate the difference between the two groups. So to do that, it's just a formula. It's the mean of group 2 divided by the mean of group 1 minus 1. And then we change that into a percentage. So we do that by doing equals, open parentheses. Instead of typing in 69.4, that's, 90.2, I'm just going to highlight it and then hit divide by mean of group 1, close the parentheses, and then minus 1. Enter. Now, when you do it, it's probably going to be that number, 0.299. So all you have to do is go up and just change it to percentage. So there's a 30% difference between individual and group work, or students that were under the condition of group work, their scores were 30% better than individual students who were in the individual work condition. Okay, so it's a real simple calculation to do. The test statistic, the significance, the Cohen's d effect size, and then the bar graph. So that's what we have left. Now, to run the t-test, you have to use the data analysis tool pack. So we go up to data, go over to data analysis, click on that. And at the very bottom of the data analysis tool pack, you'll see 3 different types of t-tests. The first one is a paired sample, and then the second 2 are the 2 sample, or the independent sample. And we can always use that first one, assume equal variances. Most of the data that we run in school settings, they're equal variances. It's not an issue. So we click OK. The variable range 1, click the up arrow, grab the individual work, the label as well, because I want that to show up on the output report. Go to variable 2 range, group work on down to the end, click the down arrow, and then I did click on the labels, and then the output range, let's put it right here, and then click OK. Now, we see a lot of different numbers. Really, we're only looking for the t-test statistic. Here it is right here. Copy, and we'll paste that number right in there. And then we can also reduce the decimals. And we'll also center it up. Now, the second thing that we want to look at, Excel runs 2 different types of p values, the formula. We either use a one-tailed test or a two-tailed test. If you don't know whether or not one is going to be better than the other, then just use a two-tailed test. So here it is right here. And if you'll remember, when we have E dash and a number at the end, it means we move that decimal point over 13 times. So 1, 2, 3, 4, so forth. And so it's a really small number, 0.0. I think I went overboard with my fake data. So if you remember how to write that, it's P. We don't say equal. If it was P equals like 0.234, then we would put P equals 0.234. But if it's less than 0.001, we say P is less than 0.001. And that's how we write it. Is that number right there, is that p-value, one-tailed test, less than 0.05? Yes. So we reject the null hypothesis. The null hypothesis is that there is no difference between the two groups. We reject that, and we say that there is a difference. Now, our effect size, this is where we determine how big of a difference is it. What's the effect size? To do that, we have to calculate Cohen's d. If you remember, with correlation, we used the test statistic R, or we also used R squared to talk about effect size. For t-tests, we use the calculation referred to as Cohen's d. So to do that, there's a lot of different calculators online to, here's one of them. This is, if I'm ever using Excel, oftentimes I'll use this one. So this is what it looks like. And you just put the mean of group 1 in, mean of group 2 here, standard deviation of both groups, and hit compute. And it will give you the number right here for Cohen's d. So let me move this. The mean of group 1 is 69.4. The mean of group 2 is 90.9. 9.2. Standard deviation from group 1 is 15.4. Standard deviation from group 2 right there is 7.2. And then we hit compute. And there it is right there. We just used the absolute number, 1.73. So again, I kind of overdid it with the fake data, but 1.73, we go down to the key to interpret the effect size. It's greater than 1.0. So these effect sizes are different than the R. The R is basically between 0 and 1. The Cohen's d is more or less, it's kind of like on a standard deviation type of unit, kind of. And so it's these two groups, their averages are like 1.73 standard deviations from each other, which is a strong effect size. So we would report it as strong. The last thing that we might want to do is to create a bar chart. And you might be tempted to like go and grabbing all of the data and then going up to insert and looking at, like here's the bar charts, and that's what it's going to give you. It makes no sense. Don't ever report a graph like that. You have to think a whole lot more simple when you do the bar graphs. So I'm going to grab the labels and let me put them right here. And you think about what we're graphing. We're actually graphing just the means. So this is the mean of group 1 is 69.4. The mean of the group work is 90.2. And so now I'm just going to highlight these four, go up to insert, and then click on the bar charts. And there we have a very simple bar chart that has individual work, group work. We can add certain things here. We can add a data table that adds the mean scores down there. We can add the axis titles, so you can put like scores here, and you can put down here like intervention condition or whatever you want. And then for the chart title, you can change the name to individual work versus group work, something like that. And there you have it. Hopefully that's helpful to you, and I've given you some other practice questions. This one takes a look at the frequent flyers and how many referrals, whether or not the referrals were reduced in the second semester after doing an intervention of restorative practices. So is there a difference between semester 1 referrals and semester 2 referrals? This is, I'll tell you right now, this is a paired sample t-test. This is the frequent flyer. This is person 1. In the first semester, they had 7 referrals. In the second semester, they had 4. Here's person 2. They had 7 in the first one, 6. So it's paired. Same person, just at a different time. The second one is more like a traditional pre-test, post-test. So is there a statistically significant difference in my students' pre-test versus post-test? And you could add the subject matter in there. So in other words, did learning take place? Again, the pre-test, this is a paired sample t-test. The first person scored a 66, and then that same person scored a 99 on the post-test. So you can work through and do that. And then if you can find some data, maybe from your own classroom, where you have 15 or 20 from group 1 and then group 2, you can do a pre-post or whatever, something, or you can make up data here if you want to. We don't normally make up data, but you can, just to kind of practice this. Think about a scenario, write your research question, and then maybe create some fake data here, and then run through a t-test. Okay, hopefully that's helpful to you, and blessings.